sklearn, preprocessing, normalize. Description. The normalize function in scikit-learn's preprocessing module rescales each sample row of a dataset individually to unit norm. This means that the length of each data point vector becomes 1. There are multiple norms available, with the most common being the L1 norm Manhattan distance and the L2 norm Euclidean distance. Inputs: X, a NumPy array or a sparse matrix representing the dataset. Each row corresponds to a sample norm. The norm to use: L1 Manhattan distance or L2 Euclidean distance are the most common options. Default is L2. Axis along which to normalize. 0 means normalize each sample row independently. 1 means normalize each feature column independently. Default is 0. Copy, whether to create a copy of the data or perform normalization in place. Default is true. Outputs: X normalized a NumPy array or sparse matrix with the normalized data. Steps: 1. Calculate the norm of each sample row along the specified axis. 2. Divide each element in the sample by the calculated norm. Metrics: none. Normalization itself is not a metric but a data preprocessing step. Visualization plots: none. Normalization typically doesn't lend itself to visualizations. Fine-tune parameters: norm, the type of norm to use for normalization, e.g., L1 or L2. Adjust based on the desired behavior. Axis, the axis along which to perform normalization. Change to 1 if you need to normalize features independently. Copy set to false if you want to perform in-place normalization to save memory. Uncertainty methods: none. Normalization is a deterministic process and doesn't involve uncertainty. Challenges and fixes: Challenge 1, data with very different scales can cause issues in algorithms like k-nearest neighbors, where distance calculations are important. Sample use case that resulted in challenge 1, applying KNN on data with features like height in centimeters and age in years will give more weight to height due to its larger scale. Fixes to challenge 1, normalize data using normalize to ensure all features contribute equally to distance calculations. Challenge 2, using the wrong norm can lead to undesirable results. Sample use case that resulted in challenge 2, using L2 norm when L1 norm is more appropriate, can lead to distortions in data where features with large values are emphasized more. Fixes to challenge 2, choose the norm carefully based on the nature of your data and the algorithm you are using. Consult domain expertise and experiment with different norms if unsure.